be joining or not. I'm not sure, but we'll have to see.
So I had called him. He said he's at the office.
Oh, okay. Mhm. All right. That should be fine. So I think in that case we can start off the session. So, any questions, any queries from last session, anyone?
All good from my end.
Okay. So, what all topics did we cover in the last session?
We discussed about push, and then we discussed about how to fetch and all.
Yeah. So we discussed about uh, your remote references, understanding what remote references are, what it does, why we need that, right? So remote references is basically telling your Git. So it's basically creating an alias for your remote references, right? So essentially what happens is when you're sorry. So essentially what happens is when we clone the central repository, we start working with it, and then once we are ready, when we want to push it to the central repository. Now, one common way we have is like how we do a git clone. When we are doing the git clone, we give the URL, right? So now, if you're working with lots of projects, like let's say you're working with 5 repositories simultaneously or in parallel, let's say. Now, it can be difficult for us to remember the URLs for each of these repositories, right? So that's where we have an alias name that we can create, which is an easy to remember, a short name essentially. So that is where we can make use of your remote references. Now, if you are working with your git clone command, you don't have to worry about it. Git clone automatically creates one. But if you are working with the git init command, you'll have to explicitly create one alias name, right? So by default, an alias name with the name origin gets created. That's the default name that gets created. Now, if you want to change that, you can change it, but by default, that's the name that gets created. Okay. So, so we looked at how you can create your remote references, how you can list your remote references. We also looked at how you can change in case you don't like that name. Maybe you want to use your own custom name. How you can change that name as well. We looked at that also. We also discussed about your fetch and pull, git fetch and git pull. So what's the difference between these two?
Fetch will just download, but it doesn't merge the update. Push it will download and then it will merge the changes to the local repository.
Right. So essentially, your fetch, can be used when you want to know what all new changes you have. Like for example, especially if you're working with multiple people in a team, and at any point, if you want to know if there are any new changes in the central repository, and for that purpose, we can make use of your fetch command. Now, this fetch command, it will not update your local repo, meaning whatever the new changes you have in the central repository, that does not get downloaded, meaning it won't be available in your local machine. So if you want to download those new changes in your local machine, meaning merge those changes with your local machine, we can make use of your git pull command. So git pull, it's a combination of your git fetch and git merge essentially. Okay, so what it will do is it will download the new changes we have and also merge those changes with your local machine. Okay, so at any point, if you want to update your local repository with whatever the new changes you have in the central repository, at any point, if you want to update that, we can make use of your git pull command. Okay. uh, then we also looked at how you can sorry. Then we also looked at how you can create new remote repositories, get the URL to what URL the remote reference is pointing to. All that we looked at, right? So that's where we had stopped in the last session. um Sedu, did you get a chance to go through the recording?
Um, yes, Ravi.
Okay. So we'll continue from there. Just give me 2 minutes. Need to finish off something. Just one more minute, sorry. Um, mm, mm, what I wrote them for. Okay, sorry guys. Let me share my screen. Now, the next thing that I want to show you is how you can push your changes to the central repository. Now, at any point, once you're done working with your local repository, committing your changes. So basically, once you're done with everything, the next step would be for us to push those changes. Like, if you want to collaborate with other people, you want to share your changes with other people, you will need to push those changes to the central repository, right? So that's what we are going to look at. My system seems to be a bit slow today. Guys, hello, guys.
Yeah, Rabi, we can hear you.
Okay. So, yeah, so this is the repo we are looking at, right? So we have some files, right? Now you wanna push those changes. We also looked at renaming your remote references, how you can do that. The next thing I want to talk about is pushing your changes to your remote, right? Like for example, like I said, let's say you're ready with your changes. What are the changes you have done? It's finalized, and now you want to share that with other people. Like let's say I have developed some automation code. Now I want to share that with you, so I'll have to push that to the central repository. Only then you will be able to access that essentially. Okay. So for that, yeah, definitely my system is slow. Okay. Now, this is the central repo we have, right? Now, I want to push some changes to the central repository, right? So whatever the changes I've done on my local machine, it's finalized, and I want to push those changes to the central repository. So that's where push to the remote comes into the picture, all right? So when you have a project at a point that you want to share, all right? So at any point, once you have your project or your data or whatever it is, the code, whatever you have worked on, once it is at a point where you want to share that with other people, you'll have to push it to the central repository. You'll have to make it available for other people. All right. So the command for this is simple. You simply run this git push command. So git push your remote reference name and then your branch, the branch to which you want to push. That's all. So in our case, we know that. So if you run this git remote, you can find the remote reference name. By default it will be origin. This is the, we experimented with this, we changed it in the last session, so that's what we have. So I'll simply say git remote, and this is the name we have, and then the branch. Now we haven't discussed about your branch yet, but here if you go to your central repo, you should be able to see your branch. So by default you'll have only one branch. It will be either the branch with the name main or branch with the name master, either of this only. So like a year or 2 years ago, we were using master as the name, but then after that they have started changing it. So main is what you will see very often. So that will be your branch. Okay, so we'll be talking more about your branches later on. So you'll have to specify the branch. So in my case, I'll give the branch. Now, whether it's a public repository or a private repository, it will prompt you for a credentials when you're pushing the changes. See, with your public repo, you'll have full read access. Okay, so in my case, this is a public repo. All right, so I'll have full read access to this, meaning anyone can read the data, anyone can clone this repo on their machine, and they can start working with this. But if you want to push any changes to this, so you can see this is a public repo. But if you want to push any changes to this, you will need to have the access. You should be authenticated. All right, you need to have that necessary access. So even if you try pushing this, it will prompt you for the credentials. So here, if you see, if I run this command, this will prompt you. Sorry, should be git push. This will prompt you for your credentials. So only when you provide the credentials, you will be able to push it to the central repository. So unless you don't have the credentials, you won't be able to push it to the central repository, whether it's a public repo or a private repo. Now, these credentials, these are different than your login credentials, the credentials that you set up for the login things. It's different than that, right? So you need to generate the credentials. So how do you generate the credentials? You can click on your username on the right hand side, go to settings over here, and you should be able to see there's if you scroll down to the bottom, you should be able to see this developer settings. Click on the developer settings and then here these are the options you will see: GitHub apps, OAuth apps, personal access token. So GitHub apps is integrating some other applications, like let's say maybe some UI tools, any client that you've created. OAuth will be any OAuth application you're using, like SSO, one login. In my case, I had experimented with Terraform Cloud. Like this, any other application you are using, you can add that as well. All right. So here you can give the authorization, callback URL, application name, homepage URL, and all these things. So you need to register the app, and then you'll need to set up the credentials and all those. So there's a different flow for this altogether. And then you have your personal access tokens, and this is what we are going to use. So personal access tokens, you can go to this code tokens classic, and you will need to generate a token. So these are all the tokens that I have generated for my experimentation. All right. So by default, you'll not have any tokens. So here, click on generate new token and go with this option classic. This is still in the beta phase, so it's still not in. I mean, you can still work with it, but I would recommend to work with this in your production, in your organization level. So we go with this generate new token classic. and you can, this will obviously require admin privileges. So I'll give my credentials, and this will log into my, all right. So here, new personal access tokens, and you can give a name to this. Whatever name you want, you can give to it. And you can set an expiration date. So, it is recommended that you follow a rotation policy. So you can choose how many days you want. So you can set a custom as well. Like maybe let's say you want to set it for 1 year. So let's say I would like to set it for next year. You can do it. That's possible, right? But you'll need to set an expiration. All right. So you have these options. So 7 days, 30 days, 60 days, 90 days custom, and also no expiration, but this is highly not recommended. All right. And then your access. So using this token, what you are generating here, what can you do? All right. So repo status, public repo, invite someone, security events, workflow, write packages. So these are all the different access that you can do, when you're using this token. So in my case, I'm going to select everything, meaning it's an admin privilege that we are giving. All right. So we'll add everything to this. And then click on generate token. Now the token will be generated. Now AWS, sorry, GitHub does not store a copy of this. All right. Once this is generated, you have to make sure you copy this and store it on your machine where only you can access it. Others should not be able to access this. Okay, so make sure you copy. You won't be able to see it again. So once you close this page, it's gone already. If you don't save it, you'll have to again generate a new one. But this becomes my password, access token, and this is what we will be using to push our changes to the central repository. Does that make sense? Any questions until here?
Even for the public repository, do we have to generate the password? How does it
Yes,
work for the private?
it's the same way.
Okay.
So this token that we have generated, this is at your account level. It is not at the repo level. Okay,
Okay.
it is at the account level. So for this particular account, any repositories you have, you can use the same token, whether it is a public repo, private repo, or an internal repo, whatever it
Okay.
is, you can use the same one.
Okay.
Any other questions?
No, Ravi.
Okay.
No, Ravi.
All right. So now that we have our token, we can start pushing our changes. So we'll go back over here and we'll rerun, or okay, let me rerun this. So this will prompt you for the username. Now the username would be the GitHub username. Okay. So whatever your username you have, that will be your username. So we'll give the username over here, and then the password will be the token. Even if you try giving the password of your GitHub account, it will not work. Okay, because your password authentication was removed in the year 2021. Okay, so it's basically not supported. So you will have to use a personal access token for this. I'll give my username, I'll paste the token, and okay, I think I'll have to make some change. Sorry, let me add one file or a couple of files. All right, so I have a couple of files. Let me add this and let me commit this. Let's say draft code. Okay, I committed it, and now let's try pushing it. Give my username, give my password, and this will go ahead and push my changes to the central repository. So now if I go and check my central repository, my code should be updated. Whatever the repo we have, where is it? This one. And here you can see I have my index.html file, I have the terraform.tf file, and you can see the commit message. When this was updated, all that information will be available for you. So now we have our changes in the central repository. So whatever the changes we had done in the local machine is now available in the central repository. That's basically your push. So push is simply pushing your changes from your local machine to the central repository. That is, whenever you want to share that code with other people, you'll have to push it to the central repository. Questions?
So how did it recognize the the repository TGR uploads demo? Is it because of the origin name that we linked
Yes.
during git remote?
Yes. So that's where your alias names comes over here. So if you look at this one, so this is what I had used. So if you look at this, you can see to the URL that it is pointing to.
Okay. It doesn't change even if we.
Unless you manually change it, it won't change.
Oh, got it.
Yeah, so that's where your alias is used, right? So in the backend, it changes that with the respective URL and then pushes it to that respective URL. That's basically a push. So if you want to push your main branch to your origin server, then you can run this to push any commits you have done back up to the server. So git push origin. So origin is the default name we have, and then the branch name. And this will prompt you for the credentials. Once you provide the credentials, it will go ahead and push those changes to the central repository. All right. Next is inspecting a remote. Now, if you want to see more information, we did this in the last session, right? So if you want to see to which URL it is pointing to which branch it is pointing to, you can make use of this git remote show origin command. Renaming also I've showed you how you can rename. So you can simply run this git remote rename your old name and the new name, and this will go ahead and rename your references. This remote reference, if you want to change, like by default you'll have origin, but in our case we went ahead and renamed it to new underscore origin. So if you want to do that, you can make use of this git remote rename command. Now at any point, if you don't want any remote references, you can go ahead and delete it as well. So if you want to remove a remote reference for some reason, maybe you have moved the server, or you're no longer contributing to that particular project, or you're no longer using a particular mirror, you can either remove, you can either these command, either of these command to delete that remote reference. So you can say git remote remove and then the name, or you can say git remote rm and the name. Either of this will work. So let's say I don't want this one now, so I'm no longer using Ruby over here. So I'll say git remote remove and then the reference name. So this will just delete it from your local machine. It will not have any effect on the central repository. Okay, this is only on your local machine that you're doing it. So once you delete the reference to a remote this way, all remote tracking branches, so any remote branches that you're tracking and any configuration settings that you have done with that particular remote will also be deleted. And again, remember, this is only on the local machine. Okay, this does not have any effect on the central repository. Questions?
No, Ravi.
No, Ravi.
All right. Cool. Next, we are going to talk about your tagging. Now, tagging can be used when you want to create release versions. All right. So whenever, like for example, let's say you're continuously making changes and you have like a release every couple of days. Now, as a developer, you cannot wait for the release to complete, right? To kind of start of new work or add new features and all those things. Like for example, let's say you have a release on Friday, and you've already finished the work today. Now I'm not going to wait until Friday to start a new work, or until Friday once my deployment is done. I'm not going to wait for that. I want to continue working. So how do we do that, right? So I want to continue working, and then if there's new change, I want to start doing that, and also keep the old change as well, so that I do see. I also want to make sure that I don't impact the change that I've done for the Friday release, right? So that's where your tagging can be useful. So tagging can be used whenever you want to create a release version, and then mark it as a release version and continue working with the other changes. Okay, so like most version control system, Git has the ability to tag specific points in a repository history as being important. So typically people use this functionality to mark release points, like let's say version 1.0, version 2.0, version 3.0, and then so on. So in this section we will look at how you can list your tags, how you can you can create and delete your tags and the different types of tags we have. Now, how do you list your tags? So listing the tags, it's very straightforward. You just have to run this command called git tag. If there are any tags, it will simply list out those tags for you. So here, by default, we will not have any tags, just so you know. So you can say I'm getting an empty response. That means I don't have any tags. So by default, you don't have any tags. Assuming you have tags, you can run this git tag command. Now, how do you create your tags? Now, there are two types of tags that you can create. One is your light-weighted tags, and the other is your annotated tags. So a light-weighted tag is much like a branch that does not change. It just provides a pointer to a specific commit. So this is light-weighted tag is same as committing your changes. All right, it does not have any additional information. It will have information like who committed it, when it was committed, what is the change, what is the commit ID. That's all. Whereas your annotated tags will contain some additional information like who created the tag, the email address of the tagger, when it was tagged, the message for your tag. It will contain some additional information. So it is generally recommended that you create annotated tags so you can have all this information. But if you want a temporary tag for some reason, right, do not want to keep the additional information, lightweighted tags are available. So generally it is recommended that you go with the annotated tags. So let's look at how you can create this tag. So creating an annotated tag in Git is simple. So you just have to use this -a flag. So something like this, git tag -a, which specifies it's an annotated tag, the version -m, which is to pass your message, tagging message. So when you run this command, what it will do is whatever the commit you have done, it will take that commit and it will create a release version for us at that particular commit. So let's say here, I will make some changes to this file. So let's say this will be deployed as release version 1. Okay, just for the sake of example. And let me just copy this to multiple lines. Yes, I'll add this. I will commit this. So let's say changes for release version 1. And I will tag this now. So once you're done committing, so whatever the changes you have done, you can create a release version for that. So I can say git tag -a, and let's call this as version 1.0 -m, and let's say this will be version 1.0 of the app. And now I have created a tag version 1.0. So at the point where we committed, when we create a tag, so whatever changes we have in that latest commit, everything will become a part of this particular tag. Now, let's say I will make some more changes. So now I can go ahead and continue making my changes. Because I've already created a release version now, right? I can use this release version to deploy my changes. All right. So what I can do here is, let's say I'll again make some change, and let's say this will be version 2. And then again, we will add this. So let's add this. Let's commit this. Oops, sorry. This will be version 2. And now we will tag this. So git tag again -a, and this will be version 2.0. So let's say version. So now I should have two tags. Okay, version 1.0 and version 2.0. Now version 1.0 will point to version 1 of the app, and version 2.0 will point to version 2 of the app. And I can continue working, right? I don't have any impact. Right? I can continue working. And when the release time comes, I will simply pick this version and deploy, which will have only version 1 changes. And then if I have a second release, I will pick this version, which will deploy the second version for me. Like this, if you want to create your release versions, you make use of your tags. Questions?
No, Ravi.
No, Ravi.
Okay. So here the -m, it specifies the tagging message which is stored with the tags. If you do not specify a message for an annotated tag, it launches an editor. So you'll type so message is mandatory. And you can see the tag data about along with the commit that was tagged by using this git show command. Now let's say I want to see the details about version 1.0, right? So let's say git tag, and I want to say see the details about version 1.0 in here. So you can see this is the additional information that you will get when you create an annotated tag. Okay, so you can see the tag name, who tagged it, when it was tagged, what is the tagging message, and obviously you'll have the commit message as well, and also the changes. So what data, what changes you have in version 1. Now if I look at git tag version 2.0, version 2.0, so you can see this is the additional data we have in version 2.0. So when I deploy version 2.0, obviously I'll have whatever the data I have in version 1. Along with that, you're also going to add this version 2.0. So you can see here version 1. That's basically your tags. Likewise, you can create your lightweighted tags as well. Now, the only difference between your lightweighted tags and annotated tags is that your annotated tags will contain the information about the tagger, who created the tag. Lightweighted tags will not contain it. That's the only difference. So another way to tag commits is with a light weighted tags. So this is basically the commit checksum stored in a file. No other information is kept. So for this, you can, let's say I'll make one more change over here. Let's call this as version 3. Again, we will add this. We will commit this. And now we will do a tag. So git tag, and let's say version 3.0. So here, if you, I'm not giving any other information. So the difference you will see is it will not contain the information about the tagger, who created this tag. It will contain the commit message. It will show you the changes, but it will not tell you who created these tags. So if you want to capture that information also, you can create your annotated tags. But essentially, that's the only difference you have. So this time, if you run the git show on the tag, you do not see the extra tag information. This command just shows the commit. That's all. Understood the difference between lightweighted and annotated tags?
Yeah, understood, Ravi.
Okay. Next is pushing your tags to the central repository, right? So see, the whole thing about this is pushing it to the central repository, right? So how do you push the changes? One moment. So by default, git push command does not transfer the tags to the remote server. So, the git push command that we have, that is only for the changes that you have committed. Okay. Any tags that you have created will not be pushed by default. All right. So you will have to explicitly push these tags to the shared server after you've created them. So you'll have to use this one. So for this also using the push command, but there's some additional information that we will have to provide, which is the tag that you want to push. So now there are two ways you can work with this. If you have multiple tags, you can choose to push all the tags or one tag at a time. So if you want to push one tag at a time, you will use this git push origin and the tag name. And if you have lots of tags that you want to push, then you can simply pass this hyphen tags, which will push all the tags at a time in one single shot. So here I can say git push origin hyphen tags, and this will again prompt you for the credentials. It should be new origin. I'll give my username. I'll give my password, and this will go ahead and push the tags to the central repository. So now, if you go and let me refresh this. And here, if you look at this branches and tags, so if you look at the tags, you should be able to see your tags. So if I look at version 1.0, whatever the changes I have in version 1.0, it will show me those changes. So this will be version 1.0. If I change it to, let's say, now version 2.0, this will show me the changes I have in version 2.0. And likewise, if I go to the version 3.0, you see I have 3.0. So when I deploy 3.0, all this will be deployed. When I deploy 2.0, only this will be deployed. And when I deploy version 1, only this will be deployed. Questions?
No, Ravi.
No, Ravi.
All right. So here also you can see releases. So you created 3 release tags. Okay. So once you're okay with this, you can create a release. Okay. So give a title and give a name. So let's say demo, and then publish this release, and this will be marked as a release. So release is essentially you're making it available for everyone. So now you can see releases, I have one. So now what this will contain, this will contain all the code. So you can see how the is for the Linux machine, and this is for the Windows machine essentially. So this will have all the code. All right. So if you want, you can download this, and you can look at the code, and all those things are possible. That's basically what your tags are, creating your release versions. Then we have your deleting the tags. Now at any point, if you don't want any tags, example, you have a very old version of that application that you're no longer supporting, right? You can go ahead and delete those tags. So to delete a tag on your local repository, you can use the -d flag. So on your local repository, if you want to delete any tag, then I can simply say this git tag -d, and then the name of the tag that you want to delete. This will delete it only from your local machine. Okay, so only from the local machine. This will only delete on the local repository. To delete a tag from the central remote servers, you'll have to run this command. So git push origin --- delete, and then the tag name that you want to delete. This is at the central repository. So git push new origin -- delete, and then I want to delete version 1.0. So obviously I'll have to provide the credentials. One moment. Hello. Just give me one moment. Just a minute. Sorry guys, I'm back. என்னது பாப்பா இருக்கட்டும், கால் அங்க சுடுது பாப்பாக்கு, வேண்டாம். Sorry. Kids, you know, kids. Okay, so I just wanted to finish off this one, deleting the tags, right? So we give the username, we give the password. Then what this will do is this will go ahead and delete the tag in the central repository. So now here, if I let me refresh this, and now we should see only 2 tags. So you can see 1.0 is gone. So at any point, you know, if it's a, you know, you're not supporting it, it's no longer valid, or you know, you're sunsetting it, you can go ahead and delete those tags as well. So that's how you can delete your tags. So if you want to view the versions of files a tag is pointing to, you can use this git checkout command. So we'll talk about your git checkout once we start off with your branching, but that's basically what your tagging is. Questions?
Ravi, all good.
Cool.
Stop here. So tomorrow we'll start off with your branching. So we'll look at what, it's a very important concept we have. So we looked at what is branching, how you can merge your branches, and all those things we'll look at tomorrow. Okay.
Okay. By the way, congratulations, Ravi, for your second baby.
For
your second baby.
Oh, that's, I mean, not yet. It's still on the way. Next month is the due date.
Okay.
This is a relative's kid who has come at home. So
Okay.
Thank you. Yeah, I mean, next month is the due date that we have.
Okay. Sorry.
Congratulations.
Yes, Sidhu?
When I'm going to join in 2 months in November.
Nice. Cool. Congratulations, yeah. So as of now, estimated we have a September end, plus or minus here and there. So just have to wait out and see.
Okay.
What date you have, Sidhu?